Good morning, everyone. I hope all stay safe and warm in this winter storm. Let's continue our discussion in Chapter 1. We'll continue with measurement and units. So let's think about this scenario that you're piloting an aircraft and you approach the airport. How do you communicate your location and speed to the tower? It would be something like, I am 10 miles southeast from the airport. I'm flying 300 miles per hour, something like this. And pay close attention. When you communicate your position, you would say 10 miles southeast direction, right? And then your speed would be 300 miles per hour. So what is mile? What is miles per hour? So those are units. Number only has meaning when the pair with unit when you communicate things like this. So that's why we have measurement and units. Measurement is a process of comparing a quantity to a standard. Units provide standardization for accurate comparisons. And there are two major systems of units. The SI unit system, which is international system, and the imperial system, which is used by aviation industry in United States. The crucial quantities that we need to measurement in aviation are things like speed, altitude, and fuel consumption. The three fundamental SI units: the time, seconds, length, meter, mass, kilogram in SI unit. The second is coming from the length of a day. We divide the day to 24 hours, an hour to 60 minutes, a minute to 60 seconds. Now, scientifically, we use the transition of atom to define what is a second, which is much more accurate than dividing the day. And then we have typical time scale. The age of the universe is very, very old. It is 13.8 billion years old. The age of the Earth is 4.5 billion years old. Now, a typical college student is around 20 years old. That's how many seconds we have, 600 million seconds. We have 90,000 seconds in a day. It's not that much, so we have to use them wisely. And in the short time scale, we have the nuclear reaction happening in 1 times 10 to the minus 22 seconds. The meter in 1791, the meter was defined as 1 out of 10 meaning of the distance from North Pole and the equator, which is the understanding of people at that time, which is not very scientific because this distance could change, depends on where you are on the equator. So today we're using the speed of light to define what is a meter. And a human typical length scale, a typical human is about around 1 meter, 2 meter. And then our cell is about 10 micrometer. Then we have nanotechnology, which is 10 to the minus nanometer. And the radius of the universe is 10 to the 26 meter. We have millimeter, centimeter, kilometer, nanometer. And we can use this prefix to other quantity as well to help us simplify our expression of those across all different length time scale. The kilogram, the scientific definition is complicated. So let's make it simple. So at the very beginning, people just decide the mass of this metal is 1 kilogram, and all the other mass refers to this. Its meaning is really how much matter it contains in this object. Now, the imperial unit system, we have foot for length, pound for mass and gallon for volume. So we need to be familiar with the conversion between SI unit and imperial unit. 1 meter to 3.28 feet roughly, 1 kilogram to 2.2 pound roughly, 1 liter to 0.264 gallon roughly. And we have to, when you fly, especially when you fly international flight, you have to convert between Celsius degree and Fahrenheit degree. The practical measurement we have in aviation are speed. It can be meter per second, kilometer per second, kilometer per hour, knots, Mach number. Mach number refers to compared to the speed of sound in the air, the multiple of speed of sound in the air. And then we have altitude, which is measured above sea level. It can be in meter or feet, depends on your unit system. We have fuel consumption, liter or gallon per hour. We have distance, feet, miles, nautical miles. We have weight, kilogram or pound, temperature, Celsius degree or Fahrenheit degree, pressure, Pascal, psi. And then we have dimension. If we have length, then its dimension is length. And then what happens if we have an area? Then it will be length times length is length squared. And if we have a volume, it is length times length times length, length to the cube. So we can have kind of operation of dimension as well. Now take speed as example. Speed is how much distance you covered in a unit time. So speed is given by length times time. Sorry, that's wrong. Speed is given by length over time. Think about how you communicate your speed to the tower. That's 300 miles per hour. So it's miles length per hour divided by time. Length, time, speed is length over time, and the acceleration is length over time squared. Acceleration times time. Acceleration is length over time squared times time. And this t and t can partially cancel. Then it will give us length over time. So acceleration times time give us speed. Speed equals acceleration times time. Now do the same thing. Speed times time. Speed is length over time. Speed is length over time times time. So this t and t can cancel, give us length, just length. So speed times time give us length. Now speed is acceleration times time. So acceleration times time squared will give us a dimension of length. So this is how displacement is related to acceleration at time. We'll learn that in next chapter. So we have the rules now. So we can do algebra with unit. We can only add or subtract things with the same dimension. Like you can only add a length to a length. So adding 1 meter and 1 meter per second doesn't make sense at all because they are different. They have different dimension. You can only equal stuff with the same dimension. So 1 meter cannot equals to 1 meter per second. That doesn't make sense either. Because on the left is the length, on the right hand is the speed. They can never be equal. Trigonometry function. So what's inside those trigonometry function has to be dimensionless. What's inside log and exponential has to be dimensionless as well.